Alright, so let's review how to find equations of lines in various forms. Okay. So first of all, there are three ways to represent the equation of a line. Okay. There's standard form, slope-intercept form, and point-slope form. Okay. So here's an example right here of standard form. And basically, when an equation is in standard form, and when a linear equation is in standard form, basically the three requirements are x and y are together on one side of the equal sign. X is positive, and you should have no fractions. Okay, those are the requirements for standard form. Slope-intercept form. Slope-intercept form. The requirements pretty much y is by itself and positive. And point-slope form looks like this, where you have y minus y1 is equal to m times x minus x1, and basically the y1 and the x1 represent a point that's on the line, and m is the slope. Okay, and you don't have to put the parentheses over here. It could just be y minus 5 is equal to negative 4 parentheses x plus 1. I mean, these two mean the same thing. Okay, so this would be point slope form. Now when we're finding the equation of a line, we always basically we plug everything into point slope form. In order to use point slope form, you need to know the slope and one point on the line, right? At least 1 point on the line. So there's different ways to do these problems. I'm always gonna start with point slope form and change it to whatever other form I need. Okay, so I always use point slope form. Okay, so let's take a look at example 1 here. So we need to find the equation of the line in slope-intercept form. So make sure you guys understand what form you want it to be in at the end through these 2 points. Well, first of all, I need to find the slope. So if I find the slope, remember you have to use your slope formula. This is your x1, y1, x2, y2. And we're basically taking y2 minus y1 all over x2 minus x1. And then the negative there, that's going to make a positive. So it looks like our slope is going to be positive 1 over negative 10. So that's our slope, all right? Positive 1 over negative 10. Now that we have the slope and we have some points, right? Both of these points are on the same line. So just pick one of them. Let's say I use these coordinates, right? So I'm going to plug it into point slope. So point slope says y minus whatever y1 is. Well, so this would be your y1. Okay, so negative 2 is equal to our slope, negative 1 over 10, times x minus whatever x1 is. In this case, it's 6. Well, over here, the negative and negative is going to become positive. So we have y plus 2 is equal to negative 1 over 10 times x minus 6. And we need to change this to slope-intercept form. Okay, now since I'm changing it to slope-intercept form, basically I want to get the y by itself, right? What I'll do is I'll just distribute this over here. So I end up with negative 1 over 10x. And I multiply there, well, that's going to give me a positive 6 over 10, right? And over here I have y plus 2. Well, I need to get the y by itself, so I minus 2, I minus 2 here. So I'm going to get y is equal to, and then over here I'll just get common denominator. So basically I put a 1 underneath here. If I get common denominator, this is just going to basically become, if I multiply top and bottom by 10, negative 20 over 10, right? So I simplify this, I get negative 1 over 10x. I simplify this, that'll give me negative 14 over 10. And I could just reduce that right there. That's going to reduce to divide top and bottom by 2, 7 over 5. So my equation is going to be y is equal to negative 1 over 10x minus 7 over 5. So that's the equation of the line in slope-intercept form. Okay? Alright, so let's take a look at our second example here. So we need to find the equation of a line in standard form this time through these 2 points. So once again, we need to find our slope. So here's our x1, y1, x2, y2. So we have 4 minus -1 all over -2 minus -5. So the two negatives next to each other become positives. So we're going to end up with +5 over +3. So that's our slope. And once again, once we have the slope, we're going to take this information and plug it into point slope. So you could use either of these points, okay? It doesn't matter if you use this one or this one. Let's say I use this one this time. So I'm going to use this point here and this slope, plug it into point slope. So we're going to end up with y minus, right here our y value is 4, is equal to our slope 5/3 times x minus, what's our x value, -2. So the negative is going to become positive. And then we want it in standard form. So if it's in standard form, what I'm going to do is I'm going to get rid of this denominator first by multiplying by 3 over here. And then I've got to multiply the other side of the equal sign by 3. So make sure you put a parentheses around here. Put the 3 so you distribute it to both. 3y minus 12 is equal to, that cancels that. And then I'm going to take the 5 and distribute it. I get 5x plus 10. Alright? Now, since standard form, we want the x's to be on the same side with the y's and x to be positive, I'm going to leave the x over here since it's already positive, and I'm going to bring this y over here. So that would be minus 3y. And then I want to get rid of this 10, so minus 10 here and minus 10 here. That'll give me -22. Right? So here's the equation of the line in standard form, right? And it meets our requirements. X is positive, x and y are together on one side of the equal sign, and we don't have any fractions. Okay? Alright, so let's take a look at example 3 here. Okay? So we need to find the equation of a line in standard form parallel to this line that will go through this point. Okay? So let's make sure we understand what's going on in this problem here. First of all, let's find the slope of this line. If you remember, if your linear equation is in standard form, an easy way to find the slope is just doing negative a over b, right? So we have negative, in this case we have negative, what's our a value? Our a value is the number in front of the x. So in this case, -1. So negative is part of the equation. So negative, -1 over our b, which is the number in front of y. In this case, 3. Well, negative is positive, so we end up with 1/3. So our slope for this line here is going to be positive 1/3. Okay. Now you can always just do the work and get y by itself. You know, put this into slope-intercept form to find the m. You could do it that way too. But if you remember this shortcut, then I mean you could do it a lot faster. It's really up to you. So here's what's going on in this problem. So the point -2, 3, right? So there's a point right here. There's a line, right? So there's a line that with a slope of 1/3. I'll just draw it in green, some random line. Let's just say this line right here, right? The slope is 1/3. Well, there's a line parallel, right? Parallel to this line, right? So a line parallel to it. So let me just draw it in, let's say, red. So there's a line parallel to this line. There's a line parallel to this line going through the point -2, 3, right? Now, if these two lines are parallel, what do you know about the slope of the second line? The slope of the second line also has to be the same as this, so it also has to be 1/3, okay? So this line here, we're trying to find the equation of this second line, right? That's parallel to this line right here. So we know the slope is 1/3 because it has to be the same, and it goes to the point what? -2, 3. So let's plug all that information into point slope. So y minus, what's our y value? 3 is equal to, what's our slope? 1/3. All right, because the slopes have to be the same because the lines are parallel. Times x minus, what's our x value? -2. So negative becomes positive. And then, hey, we need to change this to standard form, so I'm going to get rid of this denominator. I multiply by 3, put a parentheses, multiply by 3. 3y minus 9 is equal to, distribute this 1, so basically I'll get 1x plus 2. And once again, hey, if we're trying to get into standard form, the x here is already positive, so I would leave it there. I would bring the y actually over to this side, right? So I'm going to minus 3y. I'm going to get rid of the 2, minus 2 here, minus 2 here. I get negative 11. And then I've got standard form, right? So this is the equation of this line, which is parallel to this line over here, okay? And it goes through the point negative 2, 3, right? And this equation here is in standard form, right? All right, and our last example here, find the equation of a line in standard form perpendicular to this line going through this point 2, negative 4. All right, so once again, let's find the slope of this line right here. So the slope of this line, right, remember it's negative a over b if this is in standard form, which it is. So our a is the number in front of x. So it's negative, and then our number in front of x is 5. Our b is the number in front of y. In this case, it's negative 3. Well, looks like our slope is going to be positive 5 over 3. Okay, so let's understand the scenario right here. So basically, we've got a line right here, right? The slope of this line is 5/3. The point 2, negative 4, 2, negative 4. So let's say here's 2. Let's say here's negative 4. So here's this point right here. So let's say this line right here, and we can actually get y by itself and graph it and whatnot. But this line right here, let's just say it's I'll draw a green line like this. All right. So let's just pretend. All right. So this line right here, we know the slope is 5/3, right? For this line right here. This is the green line right here. Okay. Well, we're trying to find the equation of a line that is perpendicular to this line. Well, if it's perpendicular, let me kind of draw that. I'll draw one in, let's say, red. It's perpendicular and goes through the point 2, negative 4. Well, if they're perpendicular, you know that they're going to make 90 degrees, right? That's what perpendicular means. Well, if the slope of this line is 5 over 3, the slope of a perpendicular line is the opposite reciprocal. So the slope of this line has to be the opposite. So if this is positive, this has to be negative. If this is 5 over 3, we're going to flip that. We're going to get 3 over 5. Okay? So the slope of a perpendicular line is going to be negative 3 over 5. And it goes through this point right here, right? 2, negative 4. So we're going to take this information and just plug it into point slope, right? So here's a visual of what's happening so you guys understand what you're really finding, right? So we need to find the equation of this line using this information. So we have, let's see, y minus, so plug everything into point slope, y minus, what's our y value? Negative 4. Is equal to our slope, negative 3 over 5, times x minus, what's our x value? Positive 2. So the negative over here is going to become positive. So what we're going to do is I'm going to get rid of this denominator like I normally do. So I multiply by 5 on both sides, put the parentheses. So I get 5y plus 20 is equal to, these 5's cancel, and we'll distribute this negative 3. That's a negative 3x plus 6. Now since we want standard form, this x is negative, so I'm going to actually move over here so that it becomes positive, because we want x to be positive. So I'm going to move this x over here, so that'll be positive 3x plus 5y. I'm going to minus 20 on both sides here. Right? So that's going to leave me with negative 14. Right? So what we've just found right here, this is the equation of this perpendicular line, right, to this line in standard form.